Hi everyone, Mrs. Gifford here for lesson 7.6, multiplying a polynomial by a monomial. Just a quick reminder, a monomial has just one term, whether it's a constant like 7 or a variable like t, or a combination of that where it's 7t. And then a polynomial is an algebraic expression with a bunch of monomials put together. So we have our first question. How do you find the product of a polynomial and a monomial? It's as simple as using the distributive property, because we need to eliminate those parentheses. So here's our first example. We need to find this product. We have negative 6d to the third times the quantity of 3d to the fourth minus 2d to the third minus d plus 9. So as you see here, I have all my arrows drawn. Kind of reminds me of playing Angry Bird, but that is the distributive property. So what we're going to do here is take this negative 6d to the third and multiply it with each of the terms inside the parentheses. So we have negative 6d to the third times 3d to the fourth, negative 6d to the third times negative 2d to the third, negative 6d to the third times negative d. And I got to go to the last line here, or the next line. We have negative 6d to the third times positive 9. So we treat each of these terms separately, and now what we're going to do is multiply them together. So we have negative 6 times 3, which is negative 18. And we talked earlier that when you multiply by the same base, we add the exponents. So we have negative 18 d to the 7th. And then we go to the next term. So negative 6 times negative 2 is positive 12. D to the third times d to the third is d to the 6th. And then we have negative 6 times a negative 1. And I know there's no 1 right there, but it's understood that that coefficient is 1. So then we have plus 6. And then we have d to the third. And a reminder, a plain variable does have an exponent of 1. And so we have d to the fourth. So before we say we're done, we just need to look through and make sure there aren't anything else that's like terms. And we have a d to the 7th, d to the 6th, and d to the fourth. So we can't simplify them any further. So this is our finished product. Now, going on to the next topic, how do you simplify an expression? So we have more than just one term like we had before. We're going to combine these, and it's going to be two problems within one. So let's take a look at our steps here. There's two steps. One, our first step is to distribute to eliminate the parentheses. So that's the same as before. And then we're going to look through and combine any like terms that we have. So here I have the problem written down, our 15t times 10y to the third 5y squared t minus 2y times the quantity of yt squared plus 4y squared. So we've got two of these problems in one. Oh goodness, let's see. Go back to my smartboard. And I will go back to my smartboard. And so we go here and say, all right, so we're going to distribute the 15. 15t times 10y to the third t to the fifth. And then 15t times 5y squared t. So that's the first set of parentheses. Then the second set of parentheses, we're going to use that as a negative 2y out front. So we have negative 2y times the quantity of yt squared plus negative 2y times 4y squared. So I'm going to do the blue ones first, just like we did the problem before. We've got 15 times 10, which is 150. And we have t and t to the fifth. So we have t to the 6th, and there's no other y's, so we have y to the third. And we have a positive 15 and a positive 5, so that's a positive 75. And then they each have t, so t squared, y squared. Then I'm going to bring these green ones, and I've got negative 2y times y t squared. Well, there is no other number, so I've got negative 2, and I've got y and y for y squared, and then I have t squared. And then for the next part, I have negative 2 times 4. Negative 2 times positive 4 is negative 8. And then I have y times y squared, which is y to the third. So in here, we just want to make sure that we don't do or do not have any like terms. And looking down the line, I look to see if there's anything else with a t to the sixth y to the third, and there isn't. So I have 150 t to the sixth y to the third. Then I say, well, I've got t squared y squared. Well, right next to it, I have y squared t squared. Those are, sorry about this, those are like terms as well, and they're like terms because the commutative property says we can change the order. So then we say, okay, 75 minus 2 is positive 73 t squared y squared, and then all that we have left is this minus 8y to the third. So there we've distributed to get rid of the parentheses, and we've combined terms. And we don't have anything left to combine as far as our like terms, so then we would say this is our final answer for simplifying that expression. Now the last problem for today's lesson deals with solving equations that are similar to this. There are 3 steps. Just like with the first one, we're going to distribute to eliminate the parentheses. And just like the second one, once we've distributed, we look to combine our like terms. And then step 3 is going to be just to solve for the variable, using what we know about solving equations. So let's take a look at our last example. We're going to solve this equation. Looks kind of crazy, but if we take everything that we know and apply it to this problem, it really isn't as crazy as it looks. I've already put in our little Angry Bird arrows for the distributive property. So we have 2x times x, which is 2x squared, plus 2x times 4, 8x. There's nothing to distribute with this 7, so I'm going to put my plus 7, equals, there's nothing in front of the parentheses here, so we're going to put x plus 8. And then I have 2x times x, so plus 2x squared, and 2x times 1, so plus 2x, and then this plus 12 over here at the end. So now on each side of the equal sign, I'm going to combine like terms. Well, I'm looking over here on the left-hand side. There isn't anything else to combine as far as like terms. So I'm going to write my 2x squared plus 8x plus 7 equals, and as I look on this right-hand side, there's just this 2x squared, and I have x and 2x, so 1x plus 2x is 3x, and then I have my 8 and my 12, so 8 plus 12 is 20. So from here, my goal is to solve, which means I want to try and figure out what x equals. So I need to figure out how to get x to be all by itself on one side. So I am going to subtract 2x squared from both sides. Those 2x squareds cancel on both sides, which leaves us with 8x plus 7 equals 3x plus 20. Try and keep that equal sign going straight down vertically. And now I want to try and get all those x's on one side again, so I'm going to subtract 3x from both sides, and I subtract 3x because 3x is positive. So that gives me 5x plus 7. Bring my equals down, and equals 20 because those had canceled. Then I'm going to subtract 7 from both sides, and that gives me 5x. The 7's cancel. Bring my equals, and 20 minus 7 is 13. And I divide by 5. Divide by 5. So x equals 5 goes into 13, 2 and 3/5 would be our solution to this problem. And so there you have solving equations and using what you know about multiplying monomials and polynomials.